Humanity's furthest envoy travels through the immensity of interstellar space. NASA's Voyager 1, which was launched in 1977, is considered the ultimate exploration accomplishment. In addition to transforming our knowledge of Jupiter, Saturn, and their numerous moons, this mission gave us our first close-up look at the mysterious and breathtaking worlds Uranus and Neptune. As you view this film, keep in mind that the two Voyager probes are still in operation and are traveling into interstellar space, which has never been visited by a human-made object. But as they move into this unexplored region, one of NASA's famous spacecraft from the 20th century is experiencing an unnerving development. It is picking up spooky signals from interstellar space. Does Voyager simply run into an unidentified force? Do these signals represent transmissions from aliens? If yes, are they salutations or possible dangers? Come explore Voyager's incredible voyage and the puzzling signals that have fascinated scientists for decades. Voyager 1 and Voyager 2 have traveled more than 15 billion and 12 billion kilometers since launch, respectively. Think about the ambition that led to the founding of Voyager, its incredible accomplishments, and its enduring impact. Think about how these two probes and their findings have influenced later missions and even influenced NASA's work today. Imagine our sun turning into a red behemoth in the far future, billions of years from now, during quieter times. By then, Earth will no longer be livable and humanity will have followed the Voyager mission's lead and sought safety on another celestial body. The idea that the explorers will continue to serve as Earth's ambassadors even in that far-off era, each one acting as a time capsule from a time when daring explorers on our light blue reached out to the stars beyond, is both inspiring and humbling. Beyond the Voyager mission's scientific accomplishments, the probes themselves have captivated the world's attention by delivering the golden recordings, which are greetings for possible extraterrestrial civilizations. Voyager's golden records were far more ambitious than Pioneer's 10 and 11, which carried plain metal plaques. They were packed with sounds and pictures that gave prospective discoverers a glimpse of Earth's rich culture and variety of life. Combined, the Voyager mission visited more planets, found more moons, and took more pictures than any other spacecraft in NASA's history, making it one of the agency's most ambitious projects. One could wonder why there were two explorers. During NASA's early years, flying systems frequently experienced abnormalities that required safe mode, which shut off sensors until additional instructions were received. Anomalies could result in missed contacts and lost scientific opportunities because of the flyby nature of the Voyager missions. Therefore, having two spacecraft improved the mission's odds of success. Spirit and Opportunity, the Mars exploration rovers, eventually adopted this tactic. Thinking back on their extensive solar system explorations, the explorers changed our understanding of the outer planets by contributing priceless insights through tens of thousands of photos and data. They provided our first in-depth understanding of Jupiter's atmospheric dynamics, for example, demonstrating the Great Red Spot's counterclockwise spin and its interactions with lesser storms. Particularly with their groundbreaking views of the outer planets of our solar system, the Voyager missions represented important turning points in space exploration. Notably, they were the first missions to identify Jupiter's thin dusty ring. They discovered that Io, Jupiter's moon, has volcanic activity. In addition, Ganymede asserted its claim to be the largest moon in the solar system, while Europa's linear features suggested a possible subsurface ocean. They examined the makeup and structure of Saturn's atmosphere as the spacecraft passed it. Subsequent missions have validated the concept that Titan's surface contains liquid hydrocarbons, which was first proposed by Voyager 1's observations of the planet's dense cloud. Along with finding gaps and waves in Saturn's rings, the missions also helped Voyager 1 find 3 previously undiscovered moons: Atlas, Prometheus, and Pandora. While Voyager 2 headed toward Uranus, Voyager 1 continued its journey outside the solar system. Voyager 2 detected 2 unidentified rings and 11 new moons at Uranus. Some features, like Uranus's unusual magnetic field and constant temperature throughout latitudes, were still unclear, though. Neptune, the last stop on Voyager 2, revealed 6 additional moons and rings. The spacecraft discovered volcanic vents on Neptune's enormous moon Triton and investigated the planet's magnetic field and composition. In the end, both explorers entered interstellar space, crossing the heliopause, the point at which the pressure of the interstellar medium overrides the solar wind. Analysis of electron oscillations during a solar explosion indicated that Voyager 1 had officially entered interstellar space in August 2012. Since interstellar space had a higher electron density than just inside the heliosphere, this discovery went against predictions. Electron oscillations and a notable decrease in solar particles on August 25, 2012, the day Neil Armstrong died, were used to determine the departure date. Voyager 1 was now 11.5 billion kilometers away from the Sun. The enormous region between stars, known as interstellar space, is not devoid of substance. About 28% is made up of helium and 70% is made up of hydrogen, both of which came from the Big Bang. The heavier gases and dust produced inside stars and expelled into space by supernovae make up the remaining 2%. The interstellar medium is essential despite its sparseness, highlighting its critical function in the universe and acting as the birthplace of stars. For stars to form, the interstellar medium must contain both thick and thin parts. Stars are born in these areas, which are referred to as stellar nurseries or molecular clouds. Simple atoms like hydrogen and helium made up the universe at first, but when stars aged and experienced supernova explosions, they discharged more complicated elements into interstellar space. In contrast to the early cosmos, when planets were non-existent, this process made it possible for stars with planets to develop. This process depends on molecular clouds, which serve as star-breeding habitats. Planets like Earth that have the capacity to sustain life are the result of the materials in interstellar space becoming more complicated due to the developed elements found in the innards of stars. It is a historic moment as the explorers cross the heliopause, the border between the solar wind and interstellar space. It was the first man-made object to journey into this unexplored area, where neither a spacecraft nor a human-touched object has previously gone. Scientists expected to discover new things about space travel and the basic question that has captivated people for centuries: are we the only ones in the universe? The finding of exoplanets, especially those inside habitable zones and in the size range of Earth, has heightened the hunt for extraterrestrial life as we explore the expanse of the cosmos. The Drake equation gives optimism for identifying the presence of sentient civilizations, despite its many unknowns. The seeming quiet known as the Fermi paradox begs the question of why we have not yet come across extraterrestrial intelligence, given the vast potential for life in the universe. Important data from Voyager 1's voyage into interstellar space has shown how charged particles from the Sun interact with those generated by other stars and revealed severe cosmic radiation. Engineers are still amazed by the spaceship despite its age. Voyager 1 demonstrated its tenacity and possibility for longer operating life in December 2007 by effectively using its backup thrusters, which had not been utilized since 1980. Our growing technical prowess gives us optimism that we might eventually discover the answers to the universe's puzzles as we stand at a turning point in the hunt for extraterrestrial life. A signal from NASA's Voyager 1 spacecraft, which was launched 46 years ago and is currently hurtling toward the outer limits of our solar system, well beyond Pluto's orbit, was just detected by the California-based Allen Telescope Array, marking an incredible accomplishment. To connect with Voyager 1, the observatory, which is devoted to the hunt for extraterrestrial life, used 20 of its 42 dish antennas, each of which is more than 61 meters wide. The nature of the signal is still unknown, but the telescope captured 15 minutes of data that was saved on a disk. Theories concerning the signal range from the unnerving idea of aliens taking over Voyager 1 to experiences with unexplained forces in space. Although it is unclear whether the signals are a pleasant greeting or a possible danger, some even propose that they are messages from higher civilizations to humans. Voyager 1's data transmission rate is still just 160 bits per second as it continues its journey, some 15 billion kilometers from Earth and still being monitored by NASA's Deep Space Network. The probe, which is powered by a technology that turns the heat from the radioactive decay of plutonium into electricity, has produced invaluable information despite this low data transfer speed. However, NASA has difficulties keeping Voyager 1 operating since the power output drops by roughly 4 watts per year. Triage procedures have been put in place, such as shutting off the heater of the cosmic ray detector, which was previously essential for heliopause transit determination. The declining power output is a crucial factor, even though the final two instruments might continue to exist for a few more years. If all goes according to plan, the Voyagers might only be around for a few years, possibly even into the 2030s. However, these spacecraft will continue their interplanetary travels even after their instruments are silent. Our closest neighbor, Proxima Centauri, will be passed by Voyager 1 in about 16,700 years, and Voyager 2 in 36,600 years. Both will remain in orbit around the galaxy for millions of years, beyond the heliosphere's destruction and the collapse of our Sun. During their journey, these recognizable spacecraft might transmit a last message recorded on golden records made of copper that has been coated in gold and sealed in aluminum covers. These recordings contain sounds, pictures, and words intended to convey a feeling of the Earth. Despite their intended lifespan of possibly a billion years, their actual survival is dependent on environmental factors, and dust grains in space could pose a hazard. The long-term preservation of the relics from the Voyager mission may be hampered by dust particles that gradually degrade the spaceship surfaces. It has been suggested that the Voyager spacecraft's trajectories may be affected by the gravity of interstellar clouds. The spacecraft's trajectory may be bent by these enormous clouds, which are concentrated with significant mass. This could result in new orbits, sometimes even farther away or closer to the galactic core. But, tucked away against their bodies, both Voyager spacecraft carry golden recorders with etched information on their sides, reducing the likelihood of erosion over the next 5 billion years, a period during which modeling becomes difficult. It is anticipated that the travelers will live, at least in part, beyond the Milky Way's predicted collision with the Andromeda Galaxy, which will alter the galaxy's architecture as the galaxies collide and their spiral forms are warped or possibly destroyed. This durability is demonstrated. This tumultuous combination could ensnare the travelers. It is estimated that the golden records on both Voyager spacecraft will remain largely intact for more than 5 billion years. The travelers might visit stars within 150 times the distance between Earth and the Sun during this period as they vicariously tour the galaxy. Notably, they may travel through the periphery of star systems, perhaps coming into contact with unborn or non-existent stars. The circumstances surrounding the galactic merger will determine the fate of the travelers. They would stay in the galactic neighborhood, but the collision might push them out of the newly formed galaxy. At this point, collisions with high-energy cosmic rays and sporadic hits from hot gas molecules would pose the most threat to the golden records. The explorers would travel through a drastically altered cosmos in billions of trillions of years. By that time, the majority of main sequence stars would have run out of fuel, leaving a dark universe dominated by stellar remnants and black holes. The only meaningful light in this scenario would come from supernovae produced by infrequent collisions between these leftovers. The Voyager records might be witnesses to sporadic bursts of light in a dark, unidentifiable galaxy as we reflect on this far-off future. The data acquired from these documents may provide knowledge about the universe during this epoch. The Voyager missions represent humanity's pursuit of cosmic knowledge and comprehension. Along with carrying scientific instruments, they represent our hopes and dreams as they go through the emptiness. The inventiveness and tenacity that led to the development of these probes are demonstrated by each signal they send back to Earth. They serve as evidence of our capacity to push the limits of exploration and go well beyond what was previously thought to be feasible. Furthermore, future missions will be significantly impacted by the knowledge gathered from Voyager's observations. Our methods for exploring planets have been shaped by the data gathered, which has opened the door for more sophisticated spacecraft. For example, the design and goals of missions like Juno and Cassini, which aim to further solve the mysteries of these far-off worlds, have been impacted by the findings made about the atmospheres of gas giants. Intriguing queries concerning the nature of the universe have also been brought up by the travelers. Discussions concerning the origins and development of planetary systems, as well as the possibility of extraterrestrial life, have been triggered by their results. Our knowledge of the various habitats found across the solar system has grown with each contact with celestial bodies, from the frozen crust of Europa to the volcanic surface of Io. The travelers turn into messengers of human existence as they continue their trek into the depths of intergalactic space. The golden records contain the stories of our planet, giving us a glimpse of its music, languages, and cultures. Our hope that some intelligent civilization may come across these artifacts and comprehend our role in the cosmos is reflected in our quest.